Disney Smith, and this is my presentation on double-muscled cattle. The possibilities of DNA technology, I think, have been pushed to the limits since the discovery of the methods of genetic engineering. And in some ways, we've benefited from this increase of knowledge on a global scale when it comes to diagnosing new diseases, cloning plants, and making new breeds of animals. But however, there's been controversy in the recent years when it comes to breeding cattle for the meat industry. And here I have two pictures of cows. Do they look like they're from the same breed? And which one looks more profitable for its meat? They're actually the same exact type of cow breed. Scientists are now questioning the growth in population of cows that have a genetic mutation called muscular hypertrophy that increases their muscle mass and produces larger animals. And I've studied websites like PETA, HStore, Science Direct, and I've used the knowledge from my past biology class to understand the origins of this mutation. And in this presentation, I will describe the science behind the mutation, its profits for meat companies, and question the ethics behind its advantages. So, Desmet in the Encyclopedia of Meat Scientists explained that the disease, which is also called double muscling, is caused by a deletion on a chromosome called myostatin that codes for the growth factors in mammals and the development of muscles. So, typically, it can be easily identified in animals that are homozygous for or completely dominant for through its physical features. So when an organism is sexually reproduced, it receives DNA from both parent cells. And depending on which gene is more dominant, it will be expressed. So the genes that are expressed are called exons, and the ones that are not expressed or cut out of the chromosome, not to be displayed on the animal, are called introns. And Desmet also says that when double muscling occurs, there is a mutation in the gene to be expressed, caused from a deletion in the exon of the chromosome, which causes the growth gene, myostatin, to be unable to regulate the production of skeletal muscle. So the most commonly associated breeds of cattle with this mutation are the Belgian Blue and the Piedmontese. And as the ratio of Belgian Blue that are affected by this mutation is higher than the amount of normal ones today, scientists are now starting to question whether this was a commonly fixed characteristic or whether some purposeful breeding went into producing more of these cows. I read about how after World War II there is a economy boom and a raise in the demand for the beef industry. So cattle ranchers began to take notice of this already naturally occurring gene that allowed them to produce more meat per cow. So I read on Michelle Lindsay's website, Homestead on the Range, and it describes how scientists produced a breed of cow that had a higher rate of muscular hypertrophy. She says that without the technology for altering the genetics of an organism on a microscopic level, Professor Hansett at the province of Liege was able to produce Belgian Blues with the double muscling mutation through selective breeding. The method that he used was line breeding. So this is a form of selective breeding that involves mating cows that have the MHLL to close relatives. And this is unlike inbreeding because it's not direct relatives, so it doesn't really have any bad effects on them. And this breed was made just for beef uses and not for dairy uses because of its increased muscle mass. Today they still serve as a valuable asset for the meat industry in both Europe and America, and the quality of the beef texture has increased, so they're very much prized. I read G. Monin's section in the same book, Encyclopedia of Meat Scientists, that gives statistics on the overall differences between the cattle who are affected by the MHLL and those who don't have the condition. Monin quotes here that for the Belgian Blues, the dressing yield is approximately 5% higher than in normal animals of the same sex, age, and breed. Because the animals have a smaller concentration of connective tissue, the meat is known to be more tender and have a softer texture. So while this appears to be a breakthrough for the meat industry and a great example of genetic engineering, we have to ask whether it's ethical or not, and how can we decipher that without knowing all the scientific details. So, as this was already a naturally occurring gene, double muscling doesn't make these cattle fall under the category of genetically modified organisms, or GMOs, because there's no artificial change in the makeup of the animal. So scientists and animal rights groups typically focus on cattle farms that inject their cows with hormones and steroids to prolong their lifespan or their growth. And although breeding double-muscled cows doesn't involve a chemical interference, there is now concern for the stress rate and biological hindrances that come with this gene. So, as much as double-muscled cattle are advantageous to ranchers and butchers, there are some red flags in the physical features of the animals. I read on Angela Henderson's article on the PETA website that explains how cows undergo quite a few health problems from the MH gene, which can lead to some premature deaths. Some of these side effects that I read were strenuous pregnancies, which often lead to C-sections, enlarged tongues, and bone, joint, and cardiorespiratory issues. So videos and images of the cow show that it's clearly uncomfortable existing in such a state, leaving scientists to decide if this is an instance where genetically modifying these cattle to be only heterozygous for this gene is an option, meaning it might not show up, or if it does, it would be with less intensity. So while it's impressive, the feats that we've made in genetic engineering and selective breeding, we have to ask those ethical questions as we advance and not just follow blindly into tampering with science. Thank you.